see one example. Let us take this expression. Okay, so here I have open bracket and close bracket. Okay, so now in as per this example, how the program will work, let us check it. Okay, so this is the input and this is output and this is stack. Okay, so initially if you are taking output expression and the stack, both are empty. Okay, this is the step 1, let us assume. Okay, now in the step 2, okay, step 2, we are reading the open bracket. Okay, we are reading the open bracket. Okay, so as per the algorithm, if it is open bracket, we need to push it into the stack. Okay, we should not display it in output, we should push it into the stack. Okay, so let us copy this. Okay, now output expression contains nothing and the stack contains the open bracket. So let us remove this open bracket from the input expression. So this is in step 2, this is the result. Okay, now let us check what is the step 3. Okay, in step 3 we are reading A. Okay, so A is an operand. If it is an operand, we need to paste it directly in the output. That is instead of a input output, let us take it as a infix and postfix. Okay, now we are reading A. Okay, so since A is an operand, directly we are moving it to the postfix expression. Okay, and step 4. In step 4, we are reading plus operator. Okay, we are reading plus operator, and since plus is an operator, okay, since plus is an operator, it must be pushed into the stack. Since the stack already contains open bracket, okay, so we cannot compare the plus with the open bracket. So until we find a close bracket, we have to wait for the open bracket. So I'm pushing the plus in the stack. Okay, now step 5. Okay, step 5. In step 5, we are reading B. Since B is an operand, we need to push it into the stack postfix expression B. Okay, and step 6. Okay, this is step 6. Okay, in step 6, the next character is a multiplication character. Okay, since it is an operator, we have to compare with the already existing operator in the stack. The already existing operator in the stack is a plus. Okay, and the multiplication operator is a higher precedency over the plus. Its priority is higher than plus. So we cannot take the plus out. So we have to push the multiplication operator also inside the stack. Now this is the stack contains open bracket plus and multiplication operator. Okay, now step 7. Okay, in step 7, see here, next what we are reading is a C. C is an operand. Since C is an operand, directly copy it to the postfix expression. Okay, now step 8. Okay, in step 8, the next character what we are reading is, listen here, next character what we are reading is a closed bracket. So if it is a closed bracket, until we find an open bracket from the stack, all the operators we need to remove from the stack and add to the postfix expression. Okay, since it is an open bracket, the next character we read is an open bracket. Okay, pop all the operators. Okay, here I will give comment, since next character is close bracket, read all characters till open bracket. Okay, till open bracket, and add to postfix, expression. So until we find open bracket, okay, until we find open bracket, all the operators as per the order. As per the order means from here, if you are popping, okay, which operator will be popped out first? The stack contains open bracket plus and multiplication operator.
Multiplication.
Yeah, multiplication will come first. So asterisk. So remove the asterisk and paste it here. Okay, and then remove plus and paste it here. Okay, and finally remove the open bracket. Okay, open bracket is not required and you should not add it to the postfix expression. Simply you have to pop it and remove it. We removed it. Now stack is empty. Okay, now stack is empty. Okay, so this is eighth step. Okay, since we read open bracket, sorry, close bracket until we find the open bracket, all the operators we popped from the stack and added to the postfix expression, and finally we removed the open bracket also. Now stack is empty, stack contains nothing. So this is eighth step. Let us check the ninth step. Okay, ninth step is the next character that we are reading is a minus. Okay, since minus is an operator, push it into the stack. Okay, and the 10th step is a D. Okay, we are reading D. D is an operand, so add it to the postfix expression. Okay, and then we are reading division operator. Okay, and the division operator is higher precedency than the minus operator, so we should not pop the minus. Instead, push the division operator. Okay, so this is 8, 9, 10, and 11. Okay, we pushed the D here. So we pushed the division operator in the stack. Okay, then 12th step is we are reading E. Okay, we are reading E. E is an operand, so we are adding it to the postfix expression directly. Okay, and in the next step, 13th step, okay, if you are taking 13th step, there is no input character. Okay, all the characters from the infix expression we read already. So infix expression is empty. Now, if stack is not empty, whatever the characters available in the stack, pop all the characters and add it to the postfix expression as per the pop operation. So this is division, and finally minus. So this is the expression. Okay, so this is the expression. Now, if you wish, we can check using our program. Infix to postfix. Using brackets, I'm giving the same expression as the input. Okay. Now let us check the output. See here, ABC star plus DE slash minus. Okay, so ABC star plus DE slash minus, division minus. The same output we are getting it here. So this is how means this is how the algorithm works whenever we are using the brackets. Okay, Rahul, got it? Any still you have doubt? Sagar, you can use I plus plus or plus plus I, no issues. In for loop, it will not make any change. It will not show any difference. Okay, so within the body of the for loop, if you are using the I plus plus and plus plus I and moving the value to any other variable, then only its value get means some changes will be there. Okay, so this is what the algorithm means, the infix to postfix algorithm with the brackets. This is how it will work. Okay, so today also you practice the programs. If you have doubt, we will discuss about it in the next session. Okay, so now we will move to the next topic, that is queues topic. Okay, so the array implementation of a stack we'll discuss in the next week. First we will discuss, now next we will discuss about introduction to queue, then queue algorithms, linked list implementation of queue, and the queue applications. Okay, so this we'll discuss in the next 2 or 3 classes. Okay, so now this is 6th session for 2nd unit. Okay, so in our last session we discussed about a stack. Okay, so array implementation of stack we will discuss in the next week sessions. Okay, so today we will discuss about queue. So like stack, queue is also a data structure. Okay, in stack, the addition of elements or deletion of elements will happen at only one end. In queue, it will happen in two ends, both the ends. Okay, so it is like your any normal queue. Okay, the ticket counter or fees counter in wherever you are finding a queue. Okay, so it is the same queue that we are going to discuss here. So if there is a queue, line of people standing in a queue, so where we will enter into the queue means at the end. Okay, so in the rear of the queue. Okay, from the queue, how the persons will get out from the queue means from the front. After paying the fees, the first person will remove from the queue, then the next person will go to the fees counter and pay the fees, then remove from the queue. So the removal will happen in the front, and addition of elements or addition of data or addition of people will happen at the rear. So this is what two ends. Okay, queue means stack means addition or deletion will happen at only one end. Queue means addition deletion will happen in rear and front. Okay, a queue is a linear list in which data can only be inserted at one end called rear. Okay, and deleted from other end called front. Okay, these restrictions ensure that the data are processed through the queue in order, means in the same order in which they received. Okay, so whatever the data entered first into the queue, that data must be processed first. Okay, whatever the data entered second, that data will be processed second. In the same order, data gets processed. Okay, so this is called as a first in first out structure. Okay, whatever the data entered into the queue first, it will be processed first in first out. Okay, so example pictures given here. Okay, bank queue, and also in computer how it will be removed. Okay, it is like any linked list or array concept. You can add the element in one end and remove the element from the other end. Okay, so if you take queue operations, if in stack we call the operations as a push and pop. Adding an element is called as a push, and removing an element is called as a pop. The same way here in queue we will call it as a NQ and DQ operations. Adding an element into the queue is called as a NQ, and removing an element from the operation in the queue is called as a DQ operation. Okay, there are four basic operations. That is adding an element in queue, deleting an element from the queue, DQ, and checking what is the value in the front, queue front, and checking what is the value in the rear, queue rear. Okay, so these are basic four operations. Okay, apart from that, additional operations, additional algorithms will be creating the queue, checking whether the queue is empty or not, checking whether the queue is full or not. Okay, so these operations will be there additionally. Okay, so these are basic operations: NQ, DQ, queue front, and queue rear. Okay, so NQ operation with an example picture, DQ. Okay, and queue front, queue rear operations. Okay, so these are given. Okay, so the algorithms and implementation we'll discuss in the next session. Okay, so before that, let us check one. Okay. Okay, so how many elements will be there after these operations in a stack? So I go to the chat window. I have posted one question. Okay, after the operations, how many elements will be there in a stack? Correct, three. Okay, which element will be in the top? Which element will be in the top? Yeah, correct. Okay, so there is chance that this kind of questions may be asked. Okay, so both for the queue operation and stack operation also. Okay, now only we started a queue. Okay, still let us try this example. Okay, so this question whether you can able to solve it. So just you know what is the NQ and DQ operation. Okay, so after these operations, how many elements will be there in a queue?